In this tutorial, we are going to take a deeper dive into what variables are, how to create them, and how to use them. In the previous tutorial, you learned that you can think of variables as containers. These containers can hold different values. The type of value they hold is dependent on the way the variable is defined. Of course, in the computer, the only thing that can really be stored are ones and zeros. So what makes one type of value different from another if they are all just ones and zeros? Well, it turns out it's just a matter of how many ones and zeros there are, and what they will be representing. Each single one or zero is known as a bit. 8 bits taken together is known as a byte. If you use all 8 bits in a byte, you can count in binary from 0 to 255. So what can we represent using the binary numbers 0 to 255? Well, positive whole numbers or integers would be the easiest thing, as it's really a one-to-one relationship. But we can represent other things too, like signed numbers, or numbers that can be positive or negative, or floating point numbers, which are numbers that have a decimal component. In these cases, we need to store the integer part of the number as well as some other information, such as its sign or the fractional part. We can also store the characters in an alphabet. The way we do this is by using a cipher. Certain numbers represent certain characters. A very common cipher of this type is known as ASCII, or the American Standard Code for Information Exchange. Originally, ASCII encoded 128 different characters, mostly found on a typewriter. Now the ASCII characters are the first 128 characters of a much larger cipher known as Unicode. For our purposes here, we will simply call character encoding ASCII. Because we can represent so many different things, we need to define what type of data the container will hold. That allows the compiler to create what is essentially an empty container waiting for us to fill with data. Although inside the computer the data is kept in binary form, it is easier for us to work in decimal numbers and our regular alphabet, although it is also common to work in hexadecimal for some things. Let's see how we can enter data in human-readable form into the following data types. The integer data type. This data type is used to store unsigned 16-bit integer values in the range of 0 to 65,535. These are our counting numbers. Integer is used to store any positive whole value. They are commonly used to store volume levels or the brightness level of lights in a room, say 0 to 100%. The S integer data type is used to store signed 16-bit integer values in the range of negative 32,768 to positive 32,767. The S integer type is used when the value may be negative. For example, some audio equipment uses negative 80 dB to positive 20 dB for volume levels. Long. This data type is used to store integer values that are too large for the integer type to contain. This data type can store 32-bit integer values in the range of 0 to 4,294,967,295. The long data type can store a really big positive number. A counter incrementing every millisecond would last 49 days before using up the range of a long number. S-long, which is short for signed long, is a data type used to store signed integer values that are too large for the S integer data type to contain. This data type can store signed 32-bit integer values in the range of negative 2,147,483,648 to 2,147,483,647. The S-long data type is also for very big numbers, but this can track positive or negative large numbers. Float. This data type is used to store signed 64-bit floating point values. This data type is commonly used for numbers with decimal points. The float variable will hold precision to 5 decimal places. This data type can store values in the range of negative 3.40282 raised to the exponent of 38 to positive 3.40282 raised to the exponent of 38. A common usage of the float data type would be storing a temperature, such as 49.58 degrees. The double data type is used to store a signed 64-bit double precision floating point value. This double variable will hold precision to 15 decimal places. This data type can store values in the range of negative 1.79769 raised to the exponent of 308 to 1.79769 raised to the exponent of 308. If you have high-resolution data to keep track of, you can use the double data type. Information from some measurement systems will provide such high-precision data, and the double can handle it. Char. This is used to store single-byte or 8-bit unsigned values in character strings. The range of these values are 0 to 255. This is the type you would choose to hold ASCII strings. Char is the standard data type used for storing text. Each char value represents a single alphanumeric character, such as A or 2. Strings of char elements can store words or phrases. Wide char. This is used to store double-byte or 16-bit unsigned values in character strings. The range of these values is 0 to 65,535. This is the data type you would choose to hold Unicode characters. If the characters that you want to represent are not available in the ASCII chart, you can use Unicode. Unicode characters are mapped onto 2 bytes instead of ASCII's single byte, so you would use the wide char definition to represent Unicode characters. In addition to the above data types, a constant container can be defined with the define constant declaration. This data type is assigned a value at the time the program is compiled and cannot be changed in runtime. Constants and variables can be used in similar situations when coding, but the power of the variable is that it can be changed dynamically in the program. Each data type that you assign to a variable uses a different amount of system memory, regardless of the actual value that the variable holds. So, you should use the smallest data type that will accommodate the values that you wish to store, in order to maximize your available memory after the program is compiled. Keep in mind, using a long variable to keep track of the up-down state of a projector screen would be a waste of system memory. You should use the integer data type instead. When naming variables, the following conventions are used. There can be no spaces. You cannot use special characters except for the underscore, and variable names cannot begin with a number. In addition to the data type that the variable container is defined with, you can also define the persistence of the variable. Let's take a look at what that means. There are 3 persistence types: persistent, volatile, and non-volatile. These persistence types tell the compiler what type of memory to use to store the value of the variable. The most common usage is volatile. Volatile memory is faster and more plentiful than non-volatile memory. In order to use volatile memory, you must define the variable as volatile. If you do not include a persistence type in your variable definition, non-volatile is assumed. Volatile persistence variables are reset to 0 when a program is loaded to the master, and are also reset to 0 upon a system reboot. Non-volatile variables retain their value in the event of a system power down or reboot, but will be reset to 0 if the program is reloaded. Variables that are defined as persistent will be reset to 0 the first time a program is loaded to the master, but subsequent reloads of the program or system reboots will not reset the value of a persistent variable. Non-volatile memory is a limited resource. For example, an NX 2200 processor has 512 megabytes of volatile memory, but only 1 megabyte of non-volatile memory. Each time you define a variable, you are using some of that memory. So if you define an integer variable, you are using 16 bits or 2 bytes of memory. Because there is a limited amount of non-volatile memory, it is important to be aware of which pool of memory the variable will be stored in. Another thing to be aware of is the scope of the variable definition. You can define variables that have a global scope and are therefore usable anywhere in your program, Or you can define them with a local scope, and they will only be available in the section of code, which is usually a function or subroutine, where they are defined. Note that globally defined variables are available inside of functions and subroutines. We'll take a look at the differences between global and local variables in the next tutorial.